Welcome to Daily Papers, the podcast where we break down interesting new research papers into something you can actually understand. Today we're talking about artificial intelligence and music. AI models can write essays, create incredible images, and even compose music. But a new paper is asking a really important question. When an AI says it understands music, is it actually listening?
Right. Or is it just very, very good at reading the sheet music? Think about it like this. I can read a recipe and tell you exactly what ingredients are in it and what the steps are. But that's not the same as actually tasting the finished dish. This paper wanted to find out if AI is a chef or just a recipe reader.
The paper is titled Evaluating Multimodal Large Language Models on Core Music Perception Tasks, and the researchers put some of the latest AI models, like Google's Gemini, through a series of musical challenges. These weren't simple name that tune questions. They were designed to test a deep, structural understanding of music.
They came up with 3 tests. The first was a rhythm test. Specifically, they wanted to see if the AI could understand something called syncopation.
Syncopation is a fancy word for rhythms that are a little bit offbeat. It's the unexpected kick or snare drum hit that makes a beat feel funky and makes you want to move. It's about violating the listener's expectations in a pleasing way. So the AIs were played a drum loop and had to score how syncopated it was.
The second test was all about melody. Can an AI recognize the same tune if it's played in a different key? For humans, this is super easy. You know the song Happy Birthday, whether it's sung by a child or by Barry White. The melody has the same shape, the same pattern of ups and downs, even if the actual notes are higher or lower.
Exactly. This is called transposition. The researchers played the AI 2 melodies and asked, are these the same tune, just in a different key? This tests if the AI understands the relationship between the notes, not just the individual notes themselves.
And the third test was about harmony. The AI had to listen to a chord and identify its quality. Was it a major chord, which we often hear as bright and happy, or a minor chord, which can sound more sad or thoughtful?
So you've got these 3 tests, one for rhythm, one for melody, and one for harmony. They cover the core building blocks of music. But here is where the experiment gets really clever. The researchers ran all these tests on the AIs twice.
And this is the crucial part. The first time, they gave the AI an actual audio file, just like you would listen to on Spotify. A real recording of a piano, a guitar, or drums. The second time, they gave the exact same music, but in a different format called MIDI.
MIDI isn't sound, it's symbolic data. The best way to think about it is like a digital piano roll. It's a perfect, clean set of instructions. Play this note at this time for this long. There's no background noise, no instrument character, no performance nuance. It's the recipe, not the cake.
And the difference in the AI's performance between these 2 formats was just staggering. Let's start with the MIDI results. When the AIs were given the clean, perfect MIDI data, the recipe, they aced the tests.
Absolutely crushed it. Near perfect scores across the board. They could analyze the syncopation, identify the transposed melodies, and name all the chords. This tells us that these models are brilliant at symbolic reasoning. If you give them the raw data of music in a clean format, they can understand the theory and the structure perfectly.
But what happened when they had to listen to the actual audio, the messy, real-world recording of the music? Their performance fell off a cliff. The accuracy dropped hugely. On the rhythm task, they struggled to count the offbeats. On the melody task, they had a hard time telling if 2 tunes were the same. They were no longer the musical geniuses they appeared to be just moments before.
So the big takeaway from the paper is what the authors call a clear perceptual gap. The AIs have a brilliant brain for music theory, but they have really bad ears. They can reason about music perfectly, but they can't perceive it reliably from an audio recording.
And this gap really matters because we don't experience music as MIDI files. We experience it through audio. All the things that make music meaningful to us, the subtle timing of a drummer, the breathy tone of a singer, the way a guitar string vibrates, that's all in the audio. Symbolic formats like MIDI strip away all of that.
The paper makes the point that for an AI to be truly useful for music, whether it's for making amazing playlist recommendations or for acting as a music teacher, it needs to have what they call audio native competence. It has to be able to listen and understand music from the sound itself, not from a sanitized, symbolic representation of it.
The researchers even tried different ways of prompting the AI, like asking it to think step by step. And while that sometimes helped a tiny bit, it couldn't fix the fundamental problem. If the AI can't hear the notes properly in the first place, no amount of clever reasoning is going to lead to the right answer.
In the end, this paper shows that while these big AI models claim to have musical understanding, they're not quite there yet. They're more like expert music theorists who can analyze a score perfectly, but struggle when they have to actually listen to a performance in a concert hall.
It's a fantastic reality check, and it gives researchers a clear direction for the future. Before we work on making the AI's musical brain even smarter, we need to build it a much better pair of ears.
A great way to put it. And that's all the time we have for today.
Thanks for tuning in to Daily Papers.